world's biggest tunnel boring machine, to an abrupt halt. It's just 1,000 feet into a tunnel that's planned to be almost 10,000 feet long. Towering cranes, sprawling cities, hyper-advanced energy grids, and ultra-precise telescopes reveal a nation rewriting the rules of engineering, infrastructure, and technology. Meanwhile, America's feats, impressive in their own right, start to feel like the past by comparison. We don't even know that we have the cards because our leaders don't understand the game. These terrifying Chinese megaprojects prove just how China is at least 200 years ahead of other countries.
Deep sea, China's colossal energy stronghold. One of the clearest signs of China's rapid technological rise lies far from its glittering skylines and high-speed rail lines. About 150 kilometers off the coast of Hainan Island, beyond the reach of casual shipping lanes, the ocean looks calm and endless. But beneath that blue surface, something extraordinary is at work. Deep Sea Number 1 isn't just another offshore gas field. It's a bold statement of engineering ambition, quietly extracting energy from more than 1,500 meters below the surface of the South China Sea. Developed and operated by the China National Offshore Oil Corporation, Deep Sea Number 1 represents far more than a successful energy project. It marks China's confident step into the ultra-deep water arena, a space once dominated by only a handful of global players. Officially entering operation in 2021, the project now delivers roughly 3 billion cubic meters of natural gas every year. To put that into perspective, it supplies nearly a quarter of the energy demand of the Guangdong, Hong Kong, Macau, Greater Bay Area. That's millions of homes powered, industries fueled, and cities kept running thanks to a structure most people will never see. At the heart of it all is the platform itself, known as Shanghai Yihao, or Deep Sea Number 1. This isn't your typical offshore rick. It's the world's first 10,000-ton semi-submersible deep-sea energy station equipped with condensate storage, and it looks every bit as formidable as it sounds. Roughly the size of 2 football fields laid side by side and rising as high as a 40-story building, this massive steel structure floats with calm authority in waters known for their unpredictability. Built in Shandong Province, Shanghai Yihao relies on a groundbreaking truss-style framework. Compared to traditional offshore designs, this structure is lighter and more efficient, but also far more complex to engineer. Every calculation mattered. Engineers had to account for shifting loads, relentless waves, corrosion, and time itself. Beneath the main deck sits a massive buoyancy tank supported by 4 towering pillars that stabilize the platform, even when offshore weather turns hostile. This isn't merely an oil and gas platform, it's a carefully balanced fortress designed to survive where the ocean pushes hardest. And while this colossal structure dominates the world beneath the waves, it's worth noting that China isn't stopping there. The Shenzhen-Zhongshan link, China's daring bridge tunnel. There are bridges, and then there's the Shenzhen-Zhongshan link, a project so daring it doesn't just cross the sea, it disappears beneath it. Opened in June 2024, this 20 billion megastructure connects Shenzhen and Zhongshan across the Pearl River Delta, cutting travel time from a tiring 2-hour drive to a breezy 30 minutes. What once felt like a small road trip now feels closer to stepping across the street. At the core of this engineering feat lies its most impressive feature, an underwater tunnel stretching 6.84 kilometers and carrying 8 lanes of traffic beneath busy shipping routes. This isn't any tunnel, it's the widest underwater shield tunnel ever built. Even more impressive is how fast it came together. The entire passage was bored in just 110 days, a pace that raised eyebrows across the global engineering community. Powering this feat was Shenzhen, a 17-meter-wide tunneling machine that looks more like a sci-fi creature than construction equipment. Think of it as a mechanical earthworm on overdrive, slicing through the seabed with astonishing precision. Each of the 500-plus pipe rings was installed with care, locking together like massive puzzle pieces to form a watertight, earthquake-resistant tunnel capable of withstanding immense ocean pressure. But the Shenzhen-Zhongshan link didn't rely on brute force alone. Engineers packed it with intelligence. Advanced monitoring systems continuously track the tunnel's condition, while Beidou satellite navigation helps manage traffic and coordinate rapid emergency responses. It's a structure that's always alert, quietly working behind the scenes to keep everything running smoothly. What makes the project even more remarkable is its environmental awareness. Instead of disruptive underwater blasting, engineers used precise mechanical rock-breaking methods, reducing noise and protecting the habitat of the endangered Chinese white dolphin. Big engineering, it turns out, doesn't have to come at nature's expense. By the time it opened, the Shenzhen-Zhongshan link had broken 10 world records and redefined what bridge-tunnel infrastructure can achieve. A seamless blend of scale, speed, and smart design, it stands as a powerful symbol of China's ambition to connect its cities in bold, unexpected ways. And this, clearly, is just the beginning. Whatever China undertakes, it has a way of bringing grand visions back down to earth, literally. The ingenuity is visible even in smaller feats like bridges, but when China's involved, is anything ever really simple?
Take the spanning thrust arch bridge as an example. An elegant, almost poetic answer to the challenge of crossing vast spaces. With its sweeping curve, it reaches from one shore to the other like a steel arrow frozen mid-flight. But the real beauty of this design isn't just how it looks, it's how it works. An arch bridge channels forces along its curve, pushing weight downward and outward so the load flows smoothly into its supports. Nothing fights gravity here. Everything cooperates with it. Every beam of steel and every slab of concrete plays a precise role, locking together like a perfectly rehearsed orchestra. The result is a structure capable of carrying enormous weight while still appearing light, balanced, and graceful. It's engineering that feels calm and confident, not bulky or aggressive. You look at it and almost forget how much pressure it's quietly holding back. What's remarkable is how modern China has taken this ancient idea, first mastered by the Romans, and pushed it to a whole new level. Using cutting-edge materials, digital modeling, and high-speed construction methods, China has transformed the arch bridge into something both timeless and futuristic. With landmarks like the Pingan Third Bridge and the Kaohsiunmin Bridge, the country now holds world records for some of the largest and most complex arch bridges ever constructed. These structures aren't just practical routes for cars and trains, they're bold statements. They rise quietly over rivers and valleys, blending technology with terrain, strength with elegance. Instead of overpowering the landscape, they follow its lines, shaping steel and concrete to complement nature rather than erase it. But connecting two sides isn't only about crossing gaps, it's also about holding the land together when nature itself threatens to pull it apart. And that's where China's mountain walls come in, the hidden backbone. Steel rebar work. If bridges and skyscrapers are the muscles of a nation, then steel rebar is the skeleton. Quiet, invisible, and completely indispensable. Concrete may look tough and unbreakable, but here's the part most people miss. On its own, concrete is great at handling compression and terrible at dealing with tension. Left unsupported, even the tallest tower or widest bridge would be a fragile giant, strong on the outside, but dangerously weak where it counts. That's where rebar, short for reinforcing bar, steps in. Made from steel rods, rebar gives concrete the tensile strength it simply doesn't have by nature. Before any concrete is poured, these rods are carefully cut, bent, and woven into dense cage-like frameworks. It's detailed, methodical work, and every bend has a purpose. Once the concrete sets around it, steel and concrete become a single system, working together like bone and muscle. The concrete resists crushing forces, while the steel absorbs stretching and bending, preventing cracks from turning into failures. This hidden partnership is what allows structures to reach skyward without collapsing under their own weight. And it's also where China quietly pulls ahead. While many construction sites around the world still depend on manual tying and on-the-spot adjustments, China has industrialized rebar work at scale. Automated assembly lines now handle much of the process, operating more like factory floors than traditional building sites. Machines cut and bend steel bars with near-perfect precision. Robotic arms tie rebar meshes faster than human hands ever could. Meanwhile, AI-powered systems track placement in real time, ensuring every rod sits exactly where engineers intended. What might take days of labor elsewhere can be completed in just hours. It's not just faster, it's cleaner, more consistent, and far more predictable. This level of coordination isn't about chasing speed alone, it's also about reliability. Every accurately placed bar strengthens the structure as a whole, reducing weak points, minimizing cracks, and lowering the risk of long-term failure. In the end, stronger skeletons mean safer buildings and fewer disasters. But even the toughest skeleton needs muscle, and in China, those muscles have been engineered to solve problems on an entirely different scale. In the world of megaprojects, concrete is far more than a simple building material. It's the quiet muscle that holds entire nations together. China, in particular, treats concrete the way an orchestra conductor treats sound, with control, precision, and an ambition that borders on the unbelievable. These aren't small pours spread out over years. We're talking about projects where millions of cubic meters of concrete are placed in a matter of weeks. What might take other countries half a decade can unfold in what feels like a single, relentless construction push. This speed isn't accidental. It's the result of planning, logistics, and experience stacked on top of each other. Batch plants run non-stop, supply chains move with military precision, and crews work in shifts that keep construction alive around the clock. Concrete never sleeps, and neither do the timelines. But raw speed alone isn't enough to pull this off consistently. A big part of China's momentum comes from carefully chosen international collaborations that blend global expertise with local execution. One standout example is Saussure, the Spanish engineering powerhouse known for its mastery of complex infrastructure. Their involvement in landmark projects like the expansion of the Panama Canal proved just how transformative concrete can be. That single expansion consumed more than 4 million cubic meters of concrete and permanently reshaped global shipping routes. It wasn't just a construction job, it was a statement about what modern engineering could achieve when scale and precision align. Now, imagine that level of effort multiplied across China's vast landscape. Bullet train corridors stretching for thousands of kilometers, megadams holding back entire river systems, colossal bridges leaping across valleys and seas. Each massive concrete pour becomes part of a larger rhythm, carefully balanced between international know-how and China's unmatched construction pace. European firms contribute design accuracy and technical refinement, while Chinese teams deliver power, coordination, and speed on an industrial scale. Together, they're not just building faster, they're redefining expectations. They're showing the world that with the right mix of expertise and execution, the limits of how quickly megastructures can rise are far higher than anyone once believed.
A solar farm might look calm and almost poetic, endless rows of panels catching sunlight, shimmering like mirrors on a still lake. But behind that quiet shine is a constant fight against one stubborn enemy: dust. Even a thin layer can slash energy output by up to 30%, quietly turning a billion-dollar solar installation into an underperforming field of glass. Left unchecked, that dust doesn't just dull surfaces, it drains profits and wastes potential. That's why in China, home to some of the largest solar farms on Earth, cleaning isn't treated as routine upkeep, it's a strategy. These massive installations stretch for kilometers across deserts, plateaus, and sun-baked plains where dust is unavoidable. Relying on slow, labor-intensive crews simply wouldn't cut it, so China took a different path. Instead, robotic cleaning systems glide across the panels like silent sentinels on patrol. These machines are designed to be gentle but relentless, using soft brushes, controlled air pressure, or advanced waterless wiping technology to remove dust without scratching the fragile surfaces. They move methodically, row by row, often working through the night when panels are cool and power demand is low. Speed is where the real advantage shows. Tasks that would take human crews days, sometimes weeks, can be completed in a single night. Integrated sensors continuously measure soiling levels and automatically trigger cleaning cycles when efficiency drops. What was once a manual chore has become a smooth, AI-driven operation that barely needs human oversight. This isn't about keeping things shiny for appearances. It's about squeezing every last watt from the sun. Cleaner panels mean higher output, steadier power flow, and a stronger renewable grid feeding homes, factories, and even those massive tunnels carved straight through mountains. In the global race toward energy independence, China is proving a simple truth. Sometimes the smallest details are what keep a revolution running.